What's going on, YouTube? It has been a while, but I am back. I wanted to do a video with the ARTY S7 board and just like a basic UART tutorial. And it's not just the Hello World tutorial. It's more about some different aspects of the UART Lite core that we're going to look at. So I'm in Vivado and I'm using 2020.1 and I'll also be using Vitis. I clicked on this create project over here, and so I'm going to create a new Vivado project, and I'm just going to call this UART example and just RTL project, and you don't have to specify sources at the time. You really want to have the Digilent board files installed for this because it's going to make it a lot easier. It'll automatically route things to the pins. And so I'm going to go down here and I'm going to select the ARTY S7-25. If you don't know how to install the Digilent board files, I'm going to leave a link in the description for you on how to do that. But you're definitely going to want to do that if you have a Digilent board. And we're going to click finish and it's going to create our project. Okay, so we've got our project manager open, and we're going to go over to create block design. You can call it whatever you want. I'm just going to keep it as the default. I'm going to click OK. Now that we have our block diagram, we're going to maximize this, and we're going to click the plus button to add some IP. And first thing we're going to add in is our Microblaze processor. So we're going to add that in, and we're going to go here to run block automation. And this is going to give us some options to kind of customize what we want to do. And since this is just a really basic project, we're just going to keep everything mostly the same, maybe add in a little bit more memory in case we wanted to do some other stuff. Debug only. We're going to want to enable the interrupt controller, and we're going to say new clocking wizard for this. That's totally fine. We're actually not going to be using interrupts in this example, but the UART Lite does have an interrupt mode that you can activate, so it's good just to have this enabled for now in case you wanted to do more with this project. So click OK, and everything's going to run. Sorry, I'm a little stuffed up right now. You can see it's building the local memory right there. Okay, so now it built all this for us. You have the interrupt, the Axie peripherals, you have our reset for our clock, you have our clock wizard, and there's a couple things we need to do here. First thing we need to do is fix this clock wizard. You'll notice that it has a differential clock in here. We have the negative and the positive right here, and we also have an active high reset. So what we need to do is double click on this clock wizard. And we're going to say clock in one. We're going to go over here to board interface, and we have three options. We can do custom, DDR clock, or sys clock, and we're going to click sys clock. So there's two clocks that are on the ARTY S7. There's a 100 megahertz clock, and then there's a 12 megahertz clock. And the sys clock is going to be that 12 megahertz clock, and the 100 megahertz clock is for the DDR clock. I'm sure you could use the DDR clock, but just for this, we're going to use the system clock. And here's what's nice about those Digilent board files is it already knows what this is. It has all the constraints and everything on it, so that's nice. We're going to go to output clocks, and we can leave it as 100. That's fine. And we're going to go down to reset type and click active low reset because that's the type of reset that's on the board, specifically on the ARTY S7 board. So we're going to click OK. It's going to recustomize our IP. The next thing we need to do is go down to this concatenation block and double click that. And we're only going to have one interrupt, so just do one. Number of ports is just one. Okay, so we're going to go up to run connection automation, clock in one, reset n, and external reset n. Just click all of those. Click OK. Now we have our reset and we have our sys clock, and reset's going to be active low, and you can see it's going to the active low reset that we just made on the clock wizard. Now we're going to add in one more thing, and that's going to be the UART Lite. So AXI UART Lite. If it lets me add it in. Sorry, the computer's a little slow when it's recording. But yeah, so we're going to drag this down a little bit, and we can double click this. We're going to want to go USB UART, and that's going to put out the proper constraints and pins on that. And then IP configuration, here's where you can put it in a different baud rate, data bits, and parity. I'm just going to keep everything the same. And I'm going to go to run connection automation, and I'm going to do all of these. So it's going to connect the slave AXI and the UART ports. One last thing is that we need to connect this interrupt all the way over to the interrupt on the AXI UART Lite. Once we've done that, we can regenerate the layout, and we can validate our design. No problems. Control S to save the design. Go to sources. And what I'm going to do is I'm going to create an HDL wrapper, and then I'm going to generate my bit stream. Okay, so the bit stream's generated successfully. You can look at it if you want, or I mean, you can look at the implemented design if you want to. I don't really want to do that, so I'm going to click cancel. And what we need to do now is we need to export our hardware, and as well as include our bit stream, because we're going to go over to Vitis. So if you go up to the top toolbar and you hit File, move down to Export, and Export Hardware. We're going to make sure Fixed is clicked, and then we're going to say Include Bitstream. I'm going to go Next, XSA file, Design 1 wrapper, and we're going to export it to our project directory, which is fine. We're going to click Next and click Finish. We're going to export our hardware platform. Then go up to Tools and launch Vitis IDE. And at this point, we are actually done with Vivado. Once Vivado opens up, it's going to want to use selected directory. I like to just make my own, so I'm going to browse to where I have the project. This is our project right here, and I'm create a new folder. Sorry, I was hitting the wrong buttons there. UART example dot Vitis. I'm just going to call it that, if I can spell it right. Oh man, there we go. And I'm going to use this as the folder, and I'm going to launch. Now that Vitis is open, we're going to first create a platform project, and we're going to project name, I'm just going to call this UART example platform. Click Next, create from hardware specification, because we already have the XSA file generated. We're going to browse for it in our project directory. Mine's in my projects, Microblaze, UART example, and here's the XSA file that we did. Just check the date on it, make sure it's the one that you did. Standalone, Microblaze 0 is fine, and finish. Go ahead and maximize this. This is going to have our board support package in it, and it's going to have some cool examples. So if we see, here's our UART Lite, we can see some different examples. Here's the header file. Here's a self-test example. If you double click on that, you can take a look at what that is, and we'll actually use this self-test in our code. But yeah, just some cool stuff in that platform. I'm going to go ahead and right click it, and I'm going to build the project so it's not, this out of date goes away. Sometimes this can take a couple seconds. All right, so now that the builder's finished, we're going to go ahead and make a new application project. And this is going to be our code, similar way to start. This is our platform that we just created, so we're going to select that from our repository, make sure it's highlighted. Click Next, application project name. We're going to call it UART Example App. Processor, it's on the Microblaze, and this is all fine. We're just going to go ahead and say hello world in C. I'll just show you what that looks like. We're going to go to our app project and source hello world.c, and here's our hello world code. So we can do this and we can run it on our ARTY board, and it's cool. It shows that the UART's working, but all it does is do hello world, and it's not the coolest thing in my opinion. So what we can also do is actually use the UART Lite functions, and I'm going to go to my GitHub. I'm going to have this repository linked in the video description, but this C file is going to be our test file, so you can go ahead and clone that or copy it. I'm just going to go ahead and copy and paste it because it's not that big of a program. So just get all of it, copy it, go back into Vitits, Control All, and paste. So let's go through this code in a little bit. First we have our includes, and well, first we have the description, and it's minimal transmit testing of the UART Lite core version 2.0, sends the entire English alphabet at 9600 baud, 8 data bits, spelled baud wrong, and no parity. The includes Xyl printf, that's Xilinx's low overhead print function. This X status, this is just some definitions for some of the parameters that we're going to be using. X parameters, that's for let's see, where is it? That's for our UART Lite core, and then X UART Lite, that's also for our UART Lite core. This X parameters, that's for like I don't actually. Oh yeah, it's for this. It's for this device ID thing. I don't know a lot about this because I'm semi-new, but yeah, you can double click on that if you wanted to learn more about that. Now we have some constant definitions. We have our device ID, which is the instance. This is 0. If we go back to Vivado, we can see that this is actually UART Lite 0. The instance is 0. So we want to make sure it has that 0 device ID in there. We're going to say our transmit data size is 26 because there's 26 letters in the alphabet. And the max size for the transmit buffer in this example is going to be 16 because that's what the size of the FIFOs are. And so we have to define that up here. Well, you don't have to define it, but I did. We have some different functions. We have these are functions that I made. UART Lite init self test, and it takes in that device ID, and then we have the send data. So that's going to be you put in your data and your buffer, and it's going to send it out. We have our data, and it's just an array of excuse me, it's just an array. And then we have our transmit buffer, same data type, and then we have the instance of the X UART Lite structure. Boom, we get into our main code, and actually I should probably explain the functions a little bit better. So this UART Lite init self-test, that's going to initialize the UART Lite, and then it's going to self-test it. So we have this status integer right here, and we're going to call the UART Lite initialize function, and those are each in if we go up here to the UART Lite.h, that's our header file for the UART Lite. There, it actually tells you, where does it tell you? Yeah, right here, initialize, so line 47, initializing configuration. So it tells you really what you need to do to get this up and running. So I highly recommend reading this. And but yeah, so there's two ways to initialize it. I don't know which one is the right way to do. I just used this one and it worked fine. Yeah, so go back down to where we were. Yeah, so we're going to call that initialize function, and we're going to reference our pointer to, or we're going to point to the instance of our UART Lite structure, and we're going to take in a device ID, which we defined up at the top. And if the status is, if it's not successful in initializing, then we're going to return a failure. Otherwise, we're going to do a self-test, and that's where this UART Lite self-test comes in. Same thing, if it's not successful, then return failure, otherwise return success. So that's what that function does. And then we also have this send data function. And the reason I made this instead of just using the built-in, where is it, UART Lite send function, is because this function, if we look at it in the header file, where is it? Oh, you can always go down to here and click on it. Oh, there we go. Okay, and if we hover over it, it's gonna pull up this little definition. And so I want you to pay attention to this. It says in a pulled mode, which is what we're doing because we're not in interrupt mode. This function will only send as much data as the UART can buffer in the FIFO. This function may need to call it repeatedly to send a buffer. And the maximum, as much data as the UART can send in the FIFO, that's 16 bytes, right? So that's where the 16 came from when we defined the buffer size. So what the function does is, instead of just using this and sending 16 bytes, what this send data function does that I made is that it'll actually send the whole buffer and call the function multiple times. And we have this unsigned integer because that's what it's going to return. That's what the UART Lite send function returns, and it's going to tell us the number of bytes that are sent. Since we're sending out the alphabet, we're going to want this to be 26 at the end of our program. So while the tx bytes sent does not equal tx data size, which is 26, so stay in this while loop. Now, what we do is I have this data buffer and I have some data. The data is larger, so the array type is larger because it's 26. It's larger than the buffer, which is a maximum size of 16. So what this is doing here is it's putting 16 bytes at a time of this data into the data buffer. Okay? So once that's done, once the data buffer fills up with 16 bytes of data from the data array, if that makes sense, then we're going to send it. And that's where this UART Lite send comes in. We send the buffer and the txbuff size, we're going to send 16 bytes. And we increment the tx bytes sent, and then we go again through the loop. If it's not equal to the data size, keep staying in the loop. If it is, then we check the tx bytes sent. If it's 26, then return. We'll just make sure all the data was sent out. Return failure and print a new line. So let's go up into our main function. We have, whoops, oh man, I'm messing this up. We have two functions, or two integers here. We have the UART Lite status and the TX status, or it's just transmit status. So first we're going to initialize the platform and then say UART Lite status, and we're going to do the initialize and self-test function. Now we have to put some data in our buffer, and we're going to start with the alphabet data. Just a simple for loop, so we're going to run through this 26 times, and we're going to start at actually 65, because in ASCII, decimal 65 is A, and then when you increment that, so the next one, decimal 66 is B, decimal 67 is C, stuff like that until you get all the way to Z. So now that we have our full data array, then we're going to call the send data function and send all that data out over the UART. Whew, that was a lot. If you have any questions, put them in the comments below, and I will include a link to the code and the repository in the description. For now, what we're going to do is right-click, and we're going to build this application project. Let's see, it gave us some warnings here. Okay, so it's done this to me before. It says variable is set but not used when it actually is used, because you can see it's actually being used right here, even though it's set right here. So I'm not sure what that means. If you have ever encountered that, let me know. It doesn't cause any problems, and sometimes even when you build it, it doesn't give you those warnings, even though it's the same code. But aside from the point, you're going to plug in your ARTY board, and first we need to program the Fpga. So go to Xilinx, not program flash, sorry. Go to Xilinx, and where is it? Program Fpga. This is our, everything here should be okay, and we're going to hit program. That's going to program it with the soft UART, with the soft processor and the UART core. And while that's doing that, I'm going to go ahead and open up a terminal. I'm going to set it up for serial, and I'm going to connect it to my Fpga. And wait for this to program. Boom, so that's fine. Now we make sure that's highlighted. If it's not, you can just click on it again and go up to the toolbar and hit this run button. And we're going to launch it on hardware as a single application debug. Click OK. Open up the terminal, and we're going to see what happens. Boom, and it said A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and then the whole alphabet, and then it says UART Lite, TX test successful. It looks like there's a little character in there that might have just been a little glitch. So what you can do is you can press the reset button on the board, and it's just going to reset and run the program again and again and again and again, and you can see it's running flawlessly. So I really hope you enjoyed this video. Any questions, put them in the comments below. I hope I explained the code okay. It's more than just a basic hello world. It actually shows you kind of what's going on and the inner workings of that UART Lite. So yeah, thanks for watching.